Hello, everybody. I'm Charlie, one of the developers at Finite. Today, I'm going to take you through the wonderful landscape of absolute horrid beta software. Today's list of horrid beta software is our little tiny tutorial series we're going to be creating for our programming language Contract. It's not. It's pretty beta. There's a lot of issues, and I'm running off documentation I've written, so I do apologize for any misconceptions that might happen throughout the tutorial. Anyways, I'd like to introduce you to Contract. Let me reopen. Contract is a statically typed imperative programming language with functional influences. Contract is designed around a small familiar core, C-style control flow and operators, Rust-flavored let var bindings, and a lightweight functional programming via lambdas, higher order functions, and a cool custom pipe operator. Here's the Contract CLI that we're going to work with. Currently, we have compile and run in one go. That is for like that's the good thing. It's like, for example, Py main.py, or Python 3 or whatever. In reality, for the long run, what you would want to do is use the -c and then you're out to compile to binary orbit files that other people can use alongside their stuff. But essentially, let's get into the our well proper documentation. Um, what we're going to do is we're going to create a hello world example for this one. We're going to make a file called hello.ct. And obviously this tutorial provides no insight as to how to use a command line, so hopefully you're already familiar with that, but let's get started. What we're going to do is, this might be familiar to developers of C#, and F#. Anyways, let's start writing our sort of main entry point. We're going to write contract, and then we'll call it, I guess, program. You don't need to call it program, it's just I'm a C# dev, so it makes sense. Then we're going to make a static function, call it main, and then we're going to write a little hello world, io.println hello world, close that, do a semicolon there. There it is. That is literally the entire thing. Then we can ccl hello .ct, and there's our hello world. Better part is shift alt and then down arrow a bunch of times. We get our hello world. That it's our hello world. It's really, I shouldn't be sugarcoating this much. Essentially, a contract is a top-level organizational unit. It's like a class or a namespace. Every program has one or more of them. For example, you could have a Vector2D contract. You could have contracts to define networking infrastructure. You could have contracts to define your kernel, your interpreter, your bytecode compiler for ObjectRT. The static fn main is the entry point where the program runs. Execution starts here. It has to be static, otherwise the runtime will flip. Technically, we could make an instance of program, or the underlying, contract, but then really that's just violating a lot of the normal things that people figure out when they're developing for object-oriented languages. And then obviously this is a call into the IO library from the standard library module that we have that just prints a line of text. For a little extra example, we can use the IO, through the IO module, we have a IO.print, which does no new line, and a read line option that, well, it reads a line. So for example, we can io.print, what's your name? And then we can var name, give it a type, string equals io.readline, and then io.println I plus name plus exclamation point, close that, and then we run it. Okay, we give it we'll give it that. What's my what I should oh probably give it a space. What's my name? Charlie. Hi. Oh, that's so cool. I love it. I'm sorry. I'm sorry. I'm flipping out on the screen reader optimized sounds. I really need to keep these active. They're so cool. Um, so essentially, what we've just done is some very, very basic, interesting, cool stuff. Next tutorial will cover how variables work. Well, actually, no, that would be bullshit. So we can cover variables in this tutorial as well. I'm probably gonna make uh not a lot of them left, but we're gonna get through them. Um, Anyways, contract is statically typed. Every value has a type, and the compiler checks that you use types consistently. For example, you can use let for values that never change and var for values that do. Um, for example, when we write a program and we have our main, we can var count var count colon int equals 0, and then let pi double equals 3.14159. Then we'll do count equals count plus 1. That's fine. But if we do pi equals so for example, if we run this, um expected, yeah, I keep forgetting the bloody um things, it runs completely fine. But if we do pi equals 3, uh it shouldn't work because pi's immutable, but apparently the compiler's having a shit show. Um, the syntax for this is var name type equals value, where the name can be anything that isn't a reserved feature in the programming language. Type is one of int, double, float, bool, or string. For example, 32-bit whole numbers, 64-bit floating point, 32-bit floating point, true or false, and text in the orders of, well, the types. And the type names are case insensitive. So if, for example, we can do var thing int equals 1, and then var second int equals 2, and then io.print ln thing plus second, but we'll do that just to make it extra jet. String concat object of type system int 32 cannot be converted to type system. Ooh. Can I do an extension method, please? Okay, we don't have uh okay. Um uh, 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 Forget about the language feature. You can obviously leave the type off when the initializer makes it obvious. For example, we can do let name equals Charlie, if I can figure out how to spell, and then io.print name, and then run it, and then obviously there's me. But for example, uh if we do let name string equals null, um you for example, okay, if we get rid of the annotation, it'll shit the bed. Yeah, it doesn't have the type. But if we do string, then it's happy. um so for example, we'll make a sort of uh test program. We will let temp equals 23.5. So that'll do our float. Var score int equals 10. Score equals score plus 5. io.print ln temp, and then we'll drop that down again. And then we'll put in here score, and then we run it. 23.5, and then we get 15 because we did score +5. So we essentially what we can do is score plus equals 5, and then that obviously that still runs, but like you know, people are gonna miss that really really much. For control flow in the sort of the basic system, programs obviously, you know, they make decisions and they repeat work. Contract has usual tools. For example, we can do var x equals 7. If x is greater than 10, then we can io.print ln I can't see for shish. Big, pardon me. And obviously else iode small. So from here, if we run this, thank you compiler. So it's small, but if it's we do 11, big. What we actually can do is io.print ln or well read ln with the string input, and then can we convert? I don't think I've actually added explicit conversion operator. No. Uh, 10, 11, still small. Okay, so apparently, we're missing some interesting stuff apparently. Another little part is if we do I is 0, while I is less than 5. Obviously we want to block, and then we can do io.print ln I, and then I equals I plus 1. But, you know, I plus equals 1 just makes much more sense. And then when we run it, 0 to 4, because, well, I is less than 5, and numbers, integer start at zeros, so it goes up. So technically we could do 1, 2, 3, 4, which if we did 6, 1, run it again, 1 to 5. That's just the obvious downsides of stuff. A little fun fact is because, as I said before, contract is C style. What we can do is for var I int equals 0, I is less than 5, I plus equals 1, and then we can io.print ln I, and then we still get the same sort of like thing, but it's using a for loop. And another part is like if you var I int equals 0, 0, right, and then forget about that, and then you get rid of the that portion, you can essentially I plus equals 1 at the bottom, and that does literally the same thing. So, for example, if we go back, a little more interesting in-depth point of this is if instead we make I is less than, well, 10, if, let's do some modulo stuff. If I equals 2, we will continue. I can manage to spell. If I is greater than 5, of course it will break. And then we can io.println I, and then run it. So we skipped 2, 0, 1, 3, 4, 5. So it's like, oh, it's cool. And then here's a little funnier portion. Instead of using for loops and then obviously chaining the if statements like this, say for example that we have a day counter equals 3. So the day is 3. What we can do is we can switch on day, right? Case 1 io.println, it is obviously Monday. Capital. So if we do case 1, case 2, case 3, then else, what we'll get is expected one. That's the runtime dying. Okay, so we have a bit of an issue. I can guarantee this. Anyways, now to properly abuse the runtime, to properly abuse a lot of the other stuff, let's write a FizzBuzz example. For the I int equals 0, 1, sorry, I is less or equal to 20, I plus equals 1, then we can, if I modulo 15 equals 0, we'll then io.println FizzBuzz, because FizzBuzz. Else if I is an modulo 3 equals 0, print fizz. Amazing. Sorry about this uneventful tutorial. I do very much apologize. I'm not used to doing tutorials. Technically, this is my first proper one, so, well. Else if 3, else if I modulo 5 equals 0. I know I'm doing something wrong here. O.println, and then buzz. Yep. Oh, caught it. Oh, no, hold on a minute. No, I'm blind. Else, and then if we run this, one, two. We're not gonna talk about that last run. We have 1, 2, fizz, 4, buzz fizz, 7, 8, fizz buzz, 11 fizz, 13, 14, fizz buzz. So it runs. I still really don't understand. Oh right, yeah. So like, you can kind of understand how the oomph of this works. So it's like, yes. The one better part that I like about this. So when I said contract has functions and programs, uh, like functional operations and stuff. If we clear out this for loop and we just get it back to the normal part, the best part about this, right, is if we can do let inc equals fun, and then here's the best part, x the pipe, technically it is the lambda creation operator, x plus 1, and then we can io.println inc 5, and then run this. We get 6. I mean, we're defining a lambda. The lambda gets stored in increment gets called, and then it works. But then again, you really don't have to like technically do this. So for example, let's take another two methods. So fn add 1 x int, and then this returns an integer. Let's do return x plus 1, and then fn square x int, then this returns int return x squared x, or x times x. Now we get to do the real fun stuff. We can let result equals 3, then the pipe greater than add 1 pipe greater than square. This gives us the operations 3 plus 1 power of 2 squared, which equals 16 theoretically. I'm doing some heavy math right now, and and then result, and then when we run it, for bloody numbers, hey, there we go. Ooh, 16. So if, for example, we do 6, that'll go 49. I was about to say 24. Another thing too is pipes work with lambdas. So for example, if we do 10 and then fun x equal greater than x plus 5, that results in so this results in 15, right? And obviously, like, why would you bother with this? Like, pipes read left to right, matching how you describe the data flow. Take 3, add 1, then square it. Nested calls read inside out. For example, let a equal square, and then in the parentheses, add 1, 3. That's inside out. Let b equals 3, or in this case, the add 1 square. This reads left to right. So we do 6, pipes into add 1, then the result pipes into square. If you've ever written a sort of like bash command, so for example, like we can ls pipe it into select object where property expand first skip wait index debug, like for example select object 1, well, you know, it does the pipe operations. The best part about this function, right? So we have fn square and fn add 1. We want to do some more interesting stuff. Let's make a function that defines all of them in one go. This is the real killer a lot of programming language enthusiasts might skip on. fn add square. This takes in x int, so we do that. Then instead of returning int, we return a lambda operator that returns int. And then this lets us do some interesting shit. We can then do let n int equals x plus 1. And then from here, we can return fun y y times y, and then when we call add square, we'll actually do like 5 pipe operator add well, actually, hold on, no. So let fun equals add a square. We'll put in 5 there, and then we want to actually we call func let n equals x plus 1 return func y fun n n plus n, so we call that, and then we do this. Theoretically expects 1 args but 0, so there we go. That's some pretty cursed stuff. So if we do 1, we'll get 4. So what we've exactly done is we've superseded both of these functions, right? And then we've essentially asked it, we're going to define a function in a lambda that we will return. So we will take in x. We'll then do a math expression on that. We'll do an expression for this. So we'll do x plus 1. So n, if for example 1 would be 2. Then we return a function that operates on n times n times n, where we pass in the value we want to add and square. We get a function in return. This function can be called later in the future. That's how we get 4. Oh, I love this. I'm sorry. I couldn't wait any longer to tell you about this. Oh my god, it's been 27 minutes. Gee, Lord. Golly gee, fiddly dee. Anyways, I should probably... Dizzy, you can do some crazy stuff with this. They support blocks too. But I'll have some more tutorials later on in the week, later on in the future, whenever the heck I manage to get to it. That'll show you more about how to do this cool programming. And I hope yous all have a fun time. And I do apologize for the crap tutorial. But take care.